Hello, enlightened geometry students. In this assignment, we are going to talk about the similar triangle theorems. What are those? Well, remember back when we were trying to figure out if triangles were congruent all the way back in the first semester, and we ended up with problems that looked like these, where we had to add stuff to the pictures and then decide if it was an example of side angle side or angle side angle? Well, we're going to do almost the same thing, except now we're going to talk about whether the triangles are similar or not. In other words, not the same shape and same size, but just the same shape. Okay, so to tell if two objects are the same shape, here we have two shapes here, you have to check three things. Number one, we have to make sure that the shapes have the same number of sides. So basically, they both have to be pentagons or they both have to be triangles. In this case, the top shape here has 5 sides, the bottom one has 5 sides. So check, these have the same number of sides. Second thing we have to check is that you run through and you look at the angles, they all got to match. 108, 111, 105, 116, 100. 108, 111, 105, 116, 100. So check all of our angles the same. And then the third thing, and this is where all the work comes in, is we have to check to see if the ratio of the sides is consistent. Are the sides proportional? All right, so if you start comparing sides, 18 in this top pentagon matches up with 36 in the bottom pentagon. That 36 is twice the size of the 18. It's 2 times bigger. We have to check to make sure all the sides are 2 times bigger. 24 times 2 is 48. 16 times 2 is 32, 20 times 2 is 40, 21 times 2 is 42. So yes, all the sides have a consistent ratio, which means these two triangles are similar to each other. However, there are some shortcuts. Like when we were talking about congruence, we had 5 shortcuts, ASA and AAS and SSS. The ones for similar, well, there's only 3 of them, SSS, SAS, and AA. And the S's and A's stand for exactly what they stood for in the first semester, except now the S's, our sides, have to be proportional, not congruent to each other. So the SSS theorem, instead of saying that 3 sides in a triangle are congruent to 3 sides in another triangle, they have to be proportional. In other words, they have the same scale factor. The side angle side rule, well, that says 2 of the sides are proportional, and then the included angle has to be congruent. So sides have to be proportional, and the angle has to be congruent. And then the AA theorem says that if 2 angles in one triangle are the same as 2 angles in the other triangle, then the triangles are similar. They have the same shape. So let's take a look at some examples of each. First, we're going to check the side-side-side similarity theorem. In other words, the 3 sides in one triangle have to be proportional to the 3 sides in the other. They're obviously not congruent. The sides in the triangle on the left are much bigger, but they don't have to be congruent. They have to be proportional. We have to compare the sides from one triangle to the other. Now, it can be tricky if the triangle is reflected or rotated. So the way you compare them is make sure you compare the biggest side to the biggest side, the smallest to the smallest. In the first triangle, the one on the left here, the biggest side is the 30. What's the biggest side in the triangle on the right? It's 18. So we'll compare 30 to 18. The smallest to smallest will be 15 to 9, and the medium to medium will be this 25 to 15. In other words, we create 3 fractions. The biggest sides, the medium sides, the small sides. Now, you'll notice, and you'll have to do this right if you're going to use the shortcut where we use decimals instead of fractions, is all my numbers here are from the big triangle on top and the little triangle on the bottom. You can have that upside down if you want, but you can't mix and match. Pick one triangle, and the measurements from the one triangle always go on top, the other triangle always on the bottom. Now, what we've been doing is converting these into fractions, but we can also turn them into decimals as well. But we need to see if these all reduce to the same thing. 30 over 18, reduce that. 25 over 15 and 15 over 9, see if they all reduce to the same thing. If you do as a fraction, they all turn out to be 5/3. If you just divided 30 divided by 18, and for all of them, you'd get 1.6 repeating for all of them. But either way, the numbers are all the same. That means the sides are proportional. So these two triangles are similar by side, side, side. So here are a couple of problems to try. We want to decide if each of these, whether they are examples of side, side, side. So you want to compare all 3 sides in one triangle to all 3 sides in the other triangle, and they have to reduce to the same number. If they do, it's side, 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 and if they don't, they are not similar to each other. So take a moment and decide for problem number, listed as number 11 up here, are these 2 triangles similar by side, side, side? Okay, so the first thing you want to do is compare the biggest number to the biggest number, the medium to the medium, and the small to the small. So that's going to be 7.5 compared to 5, 4.5 to 3, and 6 to 4. Now, again, you could have all 3 of these fractions upside down, but you can't have just 1 or 2 of them upside down. They all have to be the same way. Here I have all the measurements from the triangle on the left on top. Now, instead of turning these into a fraction, because we have some decimals in these problems, we're just going to turn these into decimals and see if our decimals match each other. So you take out your calculator and divide 7.5 divided by 5, 4.5 divided by 3, 6 divided by 4, and see if you get the same thing for all of them. And in this case, we do. We get 1.5 for all of them. That means the larger triangle is 1.5 times larger than the small triangle. That's our scale factor, and it's the same for all the sides. Since it is the same for all the sides, these triangles are similar by SSS. Try the other two. Okay, in problem number 12, we start comparing our sides. The largest to largest, medium to medium, and small to small. It's 25 over 10, 20 over 8, and 10 over 4. We're going to take all these fractions and either reduce them to reduced fraction, which you'll end up with 5 over 2, or turn them all into decimals, in which case we'll end up with 2.5. But either way, they all turn into the same thing. That means these triangles are similar by side, side, side. How about number 13? Well, on number 13 here, again, we compare all of our sides, big to big, medium to medium, small to small. The numbers here, you can get fractions or decimals, but either way, they're not all going to match. For 2 of them, we get 0.75 or 3 over 4. And for 1 of them, we get 0.79. That actually, 19 over 24 doesn't reduce at all. But the main idea here is that they don't turn into the same thing, which means these triangles are not similar to each other. Okay, now let's talk about the AA similarity rule. For 2 triangles to be similar by AA, 2 angles in one triangle have to be the same as 2 angles in the other triangle. Your first instinct might be, hey, shouldn't it be 3 angles? No, since we already know the angles add to 180, and if you know 2 of them, and 2 of them are the same, when we subtract from 180, that third one will be the same as well. So you really only need 2. So if we're looking at this picture with 2 triangles, the little one and the large one, do they have 2 of the same angles? Well, before you decide, remember back from earlier in the year, when we have 2 angles in a triangle, we should always figure out the third one before we make a decision. If you do that, if you start subtracting from 180, say if we start with the large triangle, 180 minus 70 and 50, we end up getting 60 over here. If you go to this triangle, 180 minus 70 and 60, we get 50 for the missing angle over here. Now, are 2 of the angles in the small triangle the same as 2 of the angles in the large triangle? Yes, they are. So these 2 triangles are similar by angle, angle. And it wasn't just 2. In this case, we see all 3 of them are the same, but you only really need 2 of them. So for these 2 problems listed as 3 and 5 here, see if you can decide if each one is an example of angle, angle. Okay, in problem number 3, the first thing you should note is we got an 85 degree here and an 85 degree there. Those are definitely congruent, so that's 1 pair of angles. Then you're looking for another pair of angles. Nothing's given to you, but you know the vertical angles in the middle are congruent, so that's another pair of angles. We don't even know the measurements, but that's fine. We have 2 sets of angles in one triangle, the same as 2 sets of angles in the other triangle. These triangles are similar by angle, angle. In problem number 5, before we make a decision here, we should find those blank angles. If you start to do that, start subtracting from 180. In problem number 5, the missing angle is 41 for the big triangle, and in the small triangle, the missing angle is 47. So now we do have the same angles in both triangles. These 2 triangles are similar by angle, angle. Finally, we're going to talk about side angle side similarity. Okay, so it's a mix of the 2. So we have to have 2 proportional sides and the included angle be congruent. All right, so the included angle here, pretty easy. They're both marked in red, so we have a pair of congruent angles. What we really have to do is check the sides. The angles are congruent, check. Now we check to see if the sides are proportional. To do that, we have to compare them. And when we say compare, we're talking divide or make a fraction with them. So we're going to compare the large side to the large side and small to the small. So it'll be 9 and 6 go together. And then the 6 and 4 for the other sides go together. You can reduce these fractions or turn them into decimals. Either way, we get the same thing. 9 divided by 6 is 1.5. 6 divided by 4 is 1.5. As fractions, those are both 3 over 2. It doesn't matter what the number is. What matters is they turned out to be the same thing. So the sides are proportional, and the included angle is congruent. So these 2 triangles are similar by side, angle, side. Some sample problems. Okay, so for these 3 problems, you're going to try to decide if the triangles are similar by side, angle, side. Start with problem number 15. Okay, number 15, we got a pair of congruent angles at the 50s. Next, all we got to do is compare the sides. Compare the small to the small, that's the 6 and 9, and the big to the big, 8 and 12. So you set up some sort of fractions like this, 6 over 9 and 8 over 12, see if they turn into the same thing. In this case, they both turn into 0.6 repeating, or 2/3. Or if you did it upside down, you have 1.5 or 3 over 2. But the key thing is they're the same for both, so these 2 triangles are similar by side, angle, side. Try number 17. Okay, number 17, we have a pair of congruent angles. Those 1/10s are the same, so all we got to do is compare our sides. Remember, big to big and small to small, we'd have something like this, 6/8 and 8/10. Reduce them, see if they come out to the same thing. And if you, as fractions, that's 3 out of 4 and 4 out of 5. That's not the same thing. As decimals, that's 0.75 and 0.8. But either way, they're not the same thing. So these two triangles are not similar to one another. Number 18 is a little tricky. Take note that the second triangle has been flipped. When we have one of these problems, there's basically a rotation or a reflection where the triangle's upside down. Make sure you compare the large side to the large and the small to the small. Okay, and number 18, we should know right off the bat that these center angles are congruent to each other, so the angle's taken care of. We got to compare our sides, but notice the large side in the triangle on the right is 30 and it's 25 on the left, so you got to make sure you're comparing the correct sides. You want to compare the 25 with the 30 and the 15 with the 18. So if we take these fractions and reduce them as fractions, you're going to get 5/6 for both, or 6/5. But as decimals, they're both going to turn into 0.83 repeating, either way. Or what would that be? That'd be 1.2 if you have them upside down. But either way, they all turn into the same thing, which means these triangles are similar by side angle side. Okay, so finally, here are 4 quick questions. We want to know if the triangles are similar, and if they are, is it side, 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 angle, or angle, angle? Okay, in the first picture, we don't know anything about the sides. All we know about are angles here, so we're not going to do anything with the sides. The only possibility is angle, angle. Before we decide if it's angle, angle, we want to find the third angle. So we have a 90 and a 43. We have a 90 and a 47. We need to find out if these blank angles match something. So we start subtracting angles from 180. In the first triangle, that missing angle turns out to be 47. And in the second triangle, it turns out to be 43. And now we have matching angles. So these two triangles are similar to each other by angle, angle. And here we've written a similarity statement, same thing as a congruent statement. It just got the little squiggly line instead of the congruent sign. Problem number 2. Again, we don't know anything about the sides here, so we're only checking angles. Well, we got to see what we can add to the picture. We should be able to add those vertical angles in the center. And now, even without knowing any measurements, 2 angles in one triangle are the same as 2 angles in another, so we know these triangles are similar to each other by angle, angle. In this bottom one, number 3, we don't know anything about the angles, but we know all 3 pairs of sides. So in this case, we're going to be checking to see if it's side, side, side. So we set up our proportion to, for all these things, for all these sides, 4.5 divided by 3, and then you have the same thing again, and then 3 divided by 2. In all these cases, you get, as decimals, you get 1.5 or 0.6 repeating. As fractions, you get 3/2 or 2/3 for all of them, but either way, it's the same number. So these two triangles are similar by side, side, side. Finally, the last one, we only know 2 pairs of sides, but we can tell that these center angles are congruent because they're vertical angles. So in this case, we're going to be checking side, angle, side. Make sure we compare the correct sides with each other. So if we did 20, the large one in this triangle on the right, it's got to compare with the 15 in the triangle on the left. 20/15 would be 4/3. 16/12 is also 4/3. It could be 3/4 if you did it the other way around, which could turn into 0.75 or 1.3 repeating, but any way you do it, they're all the same number. So these two triangles are similar by side, angle, side.